Sweet. So in the studio today we have Cedric Honnet.
That's
And what have
pronunciation.
you what have you created?
So this is the HiveTracker. It's a 3D positioning system that allows sub-millimetric accuracy.
Wow!
Yeah.
Like how far a sub-millimeter?
So we get something between zero 0.5 and 0.9 millimeter
Wow.
noise, basically. And yeah, so the system piggybacks on the HTC Vive system. So the lighthouses that
The like
Valve
tower
developed,
guys?
yeah, exactly. So they send a laser that can be received by these little photodiodes.
Wow.
And inside of this microcontroller that does Bluetooth, there's a very specific feature called PPI for programmable peripheral interface, and that allows doing some real-time timestamp and in parallel, and we get a pretty good accuracy, even though we don't use an FPGA, which should be the way to go, but this is a pretty cool trick.
Wow, cool. Why did you create this?
So there's plenty of reasons. The ancestor of this project called the Twiz, which is also on Hackster.
Yeah, we'll pull that up.
Okay. The ancestor was just a motion sensor and a Bluetooth processor. So the motion sensor was also 9 degrees of freedom, and you can see there's something similar on this board, which is a bit simpler but similar. The ancestor had this possibility to measure the orientation and how you tilt things. You're here also.
Oh yeah! This was my first project on Hackster. It was our collaboration, the like self-playing ukulele. But here's the Twiz, and it's gonna give me the little...
So it's loading, but basically the idea of this project was to measure like dancer's motion and do some visualization or sonification. And this one has the same feature, but I mean the same capabilities, but it can also measure the position, which was not possible before.
Wow, cool.
And so some of the reasons why we did it is that we want to be able to track various things. This particular shape has the possibility to be put on the back of a rat. So it's somehow, you can see it a bit like a wearable for a rat. Somehow.
Have you done that?
It's in progress. We're working with this lab in London.
So it's for science as well as play.
There's a big part of this project that is for research labs. So when I was developing it, most of the time I was working in Sorbonne University in Paris. There's another guy in Spain, in Valencia, and so we're a few other electron working from Singapore, from in the US also, from different places. But yeah, it's a big international collaboration with academics, and so the lab in Paris was interested in developing little tools that you could track in 3D, like a surgery tool or things like that. And there was also this interest in documenting movement of artisanal craft, like when you make it musical instruments and these kind of things.
Cool.
And so currently,
so the next when the person is playing the ukulele, we can track.
Oh yeah, that's
level
definitely
2.
Yeah, that's definitely a feature to track. The idea of this artisanal movement tracking was more like when you build it. While you're building the thing, let's say the violin, we can track your movements. And as an instrument maker, if your knowledge is disappearing, we can document it, and later with haptic feedbacks, for example, we could reteach it with better media than just video.
Wow.
That's the idea.
So what are these connectors?
So those are flex connectors that allow talking to those little photo sensors that you can see on the board, on the side of the board. The little sensors on the side, so the 4 photo sensors, they're made by Triad Semiconductors.
Cool.
They are basically a photo sensor and a little tricky chip that does pre-processing. And then the processor only does the main processor does the computation of the position.
And you're thinking about putting like extra tiny microcontrollers on here too, right?
Yeah, so there's this pretty complicated evolution of the version 1 of the Lighthouse that has some kind of encoding that makes it impossible for this current system to do
Oh,
the 3D positioning. So we would have to do a similar board, if we can call these little boards,
yeah.
with the same things plus a tiny microcontroller. So
Wow.
we still need to find the smallest microcontroller that would be easy to program and let people from the community to modify it and improve it if they
Sweet.
want.
So if anyone has a suggestion, are you looking for any particular type or like architecture or?
I don't know yet, but I'm going to China in a few
Oh
days, and
yeah.
I'm going to look for those tiny, cheap microcontrollers that would be fast enough to do it.
Uh-huh.
There's a couple of people in this community who are working on the reverse engineering, including Charles Law, who's just streaming amazing videos about it, and we were chatting
Nice.
about it at SuperCon a couple of days ago, and there's some hope. It's going to work.
Good to hear that there is hope.
Yeah.
I love hope. This is so cool to have you in here and be interviewing you specifically because you're the one who introduced me to Ben, the co-founder of Hackster,
It's
and how this
good.
whole ridiculous journey started. Ah,
It's a
plus, it's like
pleasure.
just good to see you.
Yeah. It's
Thanks for
quite
coming on the channel. I'm gonna hug you. You're fun. Thanks for watching. We'll catch you soon, and check out the HiveTracker on Hackster, as well as the previous project Twiz. Good luck in all your endeavors.